Hi, so my name is Christoph, and I would like to introduce FAME to you, our open framework for agent-based modeling of energy systems. I'll be quick, so don't worry, you will get coffee. So think about you want to create your simulation, you want to do your modeling, and all about you care is actually the modeling. So you think about the logic that you want to implement, but then you start coding and you will find out, well, I also need to think about how to get all the data into my model and how to extract all of the output of my model. So you're doing already more than you wanted to do. And then you write some configuration tools to handle all of this. And then you really want to know how these agents that you're modeling exchange data with each other and which agent comes first and what comes next and stuff like that. So you also need to think about scheduling all of these actions. And then you have your model running and then you find out it's really slow and you want to have it run faster, and you think about parallel execution of your model, and then you write down where you didn't want to go, thinking about all of this stuff that you didn't want to care about actually. So that's why we have FAME for you. So FAME reduces the code that you have regarding all of that stuff and make you think about the agent logic only, and all of the other stuff you can forget about, right? How is this done? Well, FAME organizes the exchange of the data between your agents. It organizes the execution order of the agents. It organizes how inputs go in, how outputs go out. How about parallelization? You do not need to think about any of these things at all. Everything is there from the beginning. So you write a lot less code when you do it. You're fully flexible regarding what inputs you want to have in, what outputs you want to create, how these agents interact with each other. Everything is fully flexible. You can configure it instead of coding. It runs on any device that you can think of, on any operation system, from a small laptop to a large high-performance computing cloud. Everything is scalable to your needs. Of course, it's open source, Apache 2 license, so no copyleft, no anything. And basically it helps you in the full life cycle from model development, from coding, from applying the model in the configuration phase and running it on any high performance system, for example. So we have a full life cycle support of your model, and you can check out that link if you want to see the framework. But one more thing about how it's actually, what is the workflow of this? So you write your model using the support of FAME. You create a schema file that describes your model, and then you can configure it based on that schema file. You can validate your data that you put in. You can add the data that you want. Everything is validated. You create a binary input file from that. All of this is done by FAME. And you can then run this binary input on one or multiple cores, whatever you have, and create the output file of your simulation that you can then extract to the readable CSV files, for example, from your output. And all of this is managed by FAME, so no need for you to do that. And if you want to have like proper tracking of what you're actually doing, you can add metadata to everything. Every step of that, you can add metadata to your model, to your input data, to your configuration files, to tracking what versions of the tools you were actually using and stuff like that. All of this is tracked, and you can extract these metadata, of course, and then have full traceability what you were actually doing in your simulations. And all of these metadata are therefore stored in the binary output file and can be accessed at any point, at any later stage, so you know exactly what you were doing in the past when you were running your model. One example of a FAME application is the full-blown open electricity market model Amiris. You can see it here, not for detail, but just to understand what FAME is capable of handling. You can simulate the trading and operation of power generation plants and flexibility options with Amiris. Model business-oriented behavior under uncertainty for each of these agents with a temporal resolution of at least hourly and a spatial resolution of market zones. And this runs usually on my laptop in like 10 seconds, right? So for 1 year of data. So you can perform this full simulation in 10 seconds, powered by FAME with only one computation core. Yeah, and you can check that out. Also, if you want to, of course it's also open source completely, and you can use it as you want. And if you got any questions, I'll be here, and otherwise I'll be seeing you in the coffee break. Yes. Dexter?
Dexter is a framework code in Python that allows you to distribute your work on different, but it's more oriented for EI, for intelligence artificial algorithm,
Okay.
and transfer of data between the different steps of your process. So what are the differences with this kind of tool?
I don't know it actually. I don't know Dexter, to be honest. I would have a look at it. Thank you, but thank you for the hint. Oh yeah, I'm sorry. Yeah, right. Yeah. So if the data is simulated or real data, so it's you can have real data input, kind of, and then you will simulate what happens with the energy system. So we're using like open power system database, for example, for simulation, or other open source data sources. Yeah. Thank you. Yeah, one more question.
Could you elaborate on the company, institute, network?
Okay, so we had the German Aerospace Center, and the Institute of Networked Energy Systems is one part of that, one institution. And we are a large German research corporation, basically, and our institute has about, I think, 160 people working on energy networks as physical parts of that, like actual power system integration stuff. But I'm in the Department of Energy Systems Analysis, which is 80 people working on only modeling of the electricity and energy system.
Also hardware?
Yeah, we also have hardware, yeah. Yeah. Thank you.